Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is our first class in week 8. So after this week, only 1 week of classes left in term 1B. So of course that means that you need to get your work finished and send it out to me for marking as soon as possible so that you're ready for term 2A. To participate in classes, you can join us on radio or Zoom. The instructions for joining classes are in your study guide, or you can contact your DEC or me to join classes. All PLAR Math students are welcome to attend the classes, so it doesn't matter if you signed up for radio or if you signed up for IL. All students are welcome to join classes live or to watch the recorded classes. To contact me, you can use email, phone, or send a message on Facebook. All of my contact information is on the cover page of the study guide and each lesson. Or you can also contact your DEC to get my information as well. The PLAR English classes from last term are still available on YouTube if you are working on the PLAR English. And the PLAR Math classes are being posted as I record them. So you can either go to my YouTube channel, B. Osmond WASA, or the WASA Distance Education Center channel, which has all of the classes that we are offering by Radio Zoom. And those are the classes from every term. So from last term and this term, you can go there and you can find all the classes right there. PLAR students who did not finish up in term 1A can continue working on the key questions in term 1B, so this term, and in next term. So once you start working on the PLAR, you keep going on it until the end of the school year, and then you'll just have to sign up again in the next term. Okay, so if you started working on whichever subject in term 1A, you can continue working right up until June. If you signed up in term 1B, again, continue working right up until June. PLAR students are not withdrawn at the end of the term, so you just keep working until the end of the school year. Just a reminder that starting in September, starting in this school year, we are offering all PLAR students the option of writing the culminating activity instead of doing the lessons and key questions. So even if you have already submitted some of the key questions and some of the work, you can just go ahead and write the culminating activity if you're feeling confident about that subject. If you pass the culminating activity, then you get your missing credits. You don't have to worry about doing the lessons and key questions, and you just move on to the next subject. If you're not successful with the culminating activity, then you will have to go through the lessons and complete the key questions, and then you get a chance to write the culminating activity again. So it's not just a one-time thing and you're done. You will have more opportunities to write the culminating activity in order to be successful. If you are doing the lessons and the key questions, you will notice that there are 2 types of questions in the lesson. There are the support questions and the key questions. The support questions are the practice questions. They're the questions that you do before you do the key questions. So the way the lesson is set up, you will read a section, then you will have support questions. Do the support questions, and then if you go to the end of the lesson, right before the key questions, you will find the answers to those support questions. So check your answers against the answers given there. If you're doing really well, if you're getting all or most of those questions right, then you move on to the key questions. The key questions are the questions that you submit to me for marking. They're the ones that have the marks assigned, the marks attached. Those are the questions you submit to me. Again, do not submit the support questions. They are practice. Okay? So then as you do this key questions, send them out to me for marking right away. Don't hang on to them until you've finished the entire lesson. Okay? Send them as you do them. So to submit your work, there are several different ways. The first way is to give it to your DEC, and then your DEC will send it out to us. Or if your DEC is away or your learning center is closed or you don't have a learning center, then you can submit your own work. If you're submitting your own work, you need to be sure that you write your name on your work. Okay, make sure your name is there somewhere so that we know who is submitting the work so that we have someone to return it to. Make sure you include the subject and your teacher's name as well. But definitely your name. If we have your name, we can figure out where to return the work to. If there's no name on it, then we don't know who submitted it. We don't know who to return it to. Okay, so if you're sending your own work, you can scan and email your work to studentwork@nnec.on.ca and make sure you CC it to me. Or if you have access to a fax machine at the school or the band office, then you can fax your work to us at our toll-free number. If you don't have access to a fax machine or a scanner, then you can use your smartphone. With your smartphone, you can either take photos of your work or you can scan your work and then email it to that same address, studentwork@nnec.on.ca, and CC it to me. Or you can send your work using Facebook Messenger. So you can send the scanned document or you can send photos using Facebook. If you live in Sioux Lookout or the surrounding area and you visit Sioux Lookout fairly often, then you can use our outdoor mailbox. It is located in the parking lot on the side of the building toward the post office. So you can just drop it in that box, or you can knock on our front door, not the side door. You can knock on the front door and then give it to whoever answers the door. Another option is to use Google Docs. So you can do your work using Google Docs and then send me the link. And make sure the link is shareable so that I can access your work. And of course, you can also use Google Classroom. If you want to use Google Classroom, please contact me, email me, or send me a message so that I can send you the links and the class codes, and so that I know you are using Google Classroom. Okay, at the end of Term 1B, which is coming up in just a little bit more than a week, WASA will have 2 student draws. One draw is for students who earned a credit during Term 1B, and the other one is for students who submit work during Term 1B. So for every lesson that you submit in Term 1B, your name gets entered into the draw. So if you complete all 5 lessons, then you have 5 chances to win the prize. If you complete your lessons and you complete the culminating activity, then your name will go into both draws. So you have a chance to win 2 prizes. And so just remember, there are only 2 weeks left in Term 1B, and that count includes this week. Okay, so we're going to start off with a review of what we did in our last class, which was last week on Thursday. Last week we finished up Lesson 3 with expanding expressions, and then we moved on to Lesson 4. So expanding expressions. So this is basically the distributive property of math. So for this property, when you're asked to expand an expression, you will get an expression. Remember, an expression is does not have an equal sign. So you'll get something like 6, and then you get brackets, and inside the brackets will be something like x plus 2. So when you see that and you're asked to expand, what you have to do is multiply the number that's outside, or the term that's outside the brackets, by each term that's inside the brackets. So 6 times x and 6 times 2. So you're expanding it out, you're making it bigger. Then you will simplify. So 6x, 6 times x is 6x, 6 times 2 is 12. So your answer is 6x plus 12. Once we get to this point, we can't do anything else because we have unlike terms. We have one term that has a variable, 6x, and we have one term that is just a constant, or just a number, so the 12. You can't add 6x plus 12 because they're not like terms. Okay? So just remember that. That's going back to when we did adding and subtracting polynomials. So we end up with an answer that is a polynomial, but we can't do anything with it because it's unlike. So you have to remember that when you're looking at this as well. So as I mentioned to you when we did lesson 1, whatever we did in lesson 1 will carry on through all of the other lessons. So adding and subtracting, multiplying and dividing integers, and adding, subtracting, multiplying, and dividing fractions. And then we're continuously building on what we've learned in lesson 2, lesson 3, and on into lesson 4. So this is a little bit of adding and subtracting polynomials, and they're unlike terms. Okay, the second thing we did was start lesson 4, and in lesson 4 we looked at solving equations. So lesson 3 we talked about expressions. Expressions do not have an equal sign. Equations do have an equal sign. So an equation is a mathematical expression that contains an equal sign. So some examples are y plus 6 equals 0, 3 times x minus 3 equals 12, 2x plus 2 over 4 equals x minus 3 over 3, 2x squared plus 3x minus 2 equals 0. So all of these contain equal signs. That's why they are called equations. There are two sides to an equation, with the left side being equal to the right side. So what we want to do when we're dealing with equations is keep the balance. So whatever we do on one side of the equation, we must do on the other side of the equation. We can solve equations to work out the value of the unknown, or the variables that satisfy the equation. So that's our goal, is to figure out what the value of the unknown is. And the unknown is the variable. The variable might be x, it might be y, it might be z, it might be a, it might be b. It can be whatever letter we choose it to be. But what we're trying to figure out is, what does that letter stand for? What's the value of that letter? In order to solve equations, we need to work out the value of the unknown variable by either adding, subtracting, multiplying, or dividing both sides of the equation by the same value. Excuse me. So here, first example, 10 equals z plus 6. So you can probably look at this and go, well, 10 equals, so 6 plus 4 is 10. So you might be able to do that one in your head. Okay, and a lot of times you will be able to do them in your head. But we need to know how to use the mathematical process to solve it, because sometimes you can't. So we practice with easier examples. So here what we need to do is get that z by itself. So we need to get rid of the plus 6. The opposite of plus 6 is minus 6. So that's how we get rid of it. If we subtract 6 on the right-hand side, then we have to subtract 6 on the left-hand side as well. That will leave us with 10 take away 6 is 4 equals z. So, as I mentioned, when you're looking at it, you can tell that z represents the number 4, and we solved it to show that, yes, z equals 4. Okay, the next one, q minus 12 equals 1. So we want the q by itself, so we need to get rid of the minus 12. The opposite of minus 12 is plus 12. So this time we're adding 12 to both sides. So q minus 12 plus 12 leaves us with q equals, and 1 plus 12 is 13. So q is 13. And we can check that by just substituting in. So q we said is 13, take away 12 equals 1, so that's our original. 13 take away 12 is 1, and 1 equals 1. So that's correct. Okay, the next one, 8y equals 48. Now remember, 8y means 8 times y. So this is multiplication. The opposite of multiplication is division. So I can do 8y divided by 8, because I want to get rid of the 8, equals 48 divided by 8. I can do it this way. 8 divided by 8 is 1, so I'm left with y equals 48 divided by 8 is 6. So y equals 6. Or I can do it using fractions. So 8y divided by 8 equals 48 divided by 8. Same thing, y equals 48 divided by 8 is 6. So I get the same answer, just do it slightly different. You do it the way that makes the most sense for you. If using the division symbol makes the most sense to you, then you do it that way. If using the fraction method makes the most sense, then do it that way. Okay, so here's another example. R over 3 equals 7. So again, I want to get rid of that 3. I want R to be by itself. R over 3 means divide. R divided by 3. So in order to get rid of that 3, I need to multiply by 3. Okay, so that cancels out my 3's. Oops, I forgot to put it on that side. Cancels out my 3's. I'm left with R equals 7 times 3 is 21. And I can check that. R over 3 equals 7. R over 3, 21 over 3 equals 7. 21 divided by 3 is 7. So 7 equals 7. Okay, so that's how you can check your answers to see if you got them right. Just substitute the answer that you got, R equals 21, into the original equation. All right, so that's what we did last week. So we've done solving equations. Today we're going to do solving multi-step equations, so doing more than one thing, and we're going to look at ordered pairs. So in your lesson, beginning on page 9, and we did start to look at some of this last week, but we didn't finish it. Solving an equation with a variable on both sides, and then on the next page, some examples. And a few more complicated examples, so make sure you work your way through those. And then on pages 11 and 12 is support question number 2. So make sure you do support question number 2 before you head off to your key questions. Okay, so last day, on Thursday, we looked at solving the equation with the constants on both sides. So remember, your constants are just the numbers. So what you have to do when you have something like this that is going to take more than one step is you have to decide, first of all, which side am I going to have the variables on and which side do I want my constants on. So in this case, the variable is only on one side. So we're going to leave the variable on that side. So 4x is going to stay where it is. I want that, the negative 14, that's going to be my constant side. So that means I need to get rid of that plus 6. So remember, we got to do more than one step. So 4x plus 6, I want to get rid of that, so I'm going to subtract 6. And then that means I have to subtract 6 on the right-hand side of the equal sign as well. So that leaves me with 4x equals negative 14 minus 6 is going to give me negative 20. Remember, integer rule plus negative 6. So negative 14 plus negative 6 will give me negative 20. So I did one thing. So I subtracted. Now I've got 4x, which is multiplication. So in order to do the opposite of multiplication, I need to divide. So I'm going to divide, and I want to get rid of the 4. So I'm dividing by 4 on both sides. So 4x divided by 4 will leave me with x. And then negative 20 divided by 4 will leave me with negative 5. So my answer is x equals negative 5. Okay, so we looked at that on Thursday. Now, moving on, adding on, solve an equation with variables on both sides. So now this time, instead of a constant on both sides, we have a variable on both sides of that equal sign. So again, all I have to do is decide which side I want my variables on, which side I want my constants on. Well, I only have a constant on the right, so I'm going to leave the constant and I'm going to get rid of that variable. You do it the same way as we just did with eliminating constants. So 5x, now I'm going to subtract 4x because that's a plus 4x. So minus 4x equals 4x minus 4x plus 7. So 5x minus 4x will give me 1x, or just x, equals, that's gone, and I'm left with, I'm left with plus 7. So x equals plus 7. And I actually really only have to eliminate one term. That minus sign shouldn't be there. 5x minus 4x is 1x, and then I eliminate my negative, or my x, my 4x on the right hand side, so I'm left with 7. X equals 7. Okay, pretty simple. Let's look at another example. 5y minus 8 equals 7y. So again, I've only got one constant. It's on that side, so I'm going to leave it there, which means I'm going to get rid of that 5y. So 5y minus 5y minus 8 equals 7y minus 5y. So now my 5y's are gone there. I'm left with my minus 8. It's not 8, it's minus 8 equals 7 take away 5 is 2y. So now I've got negative 8 equals 2y. I'm not finished there because I still have a number with my variable. So I have to get rid of that 2. So in order to get rid of that 2, this is multiplication, 2 times y. I'm going to do the opposite, which is divide. So that means I'm going to divide both sides by 2. Negative 8 divided by 2 is negative 4, and then 2 divided by 2 is 1, and that leaves me with my y. So negative 4 equals y. So that means my y, value for y, is negative 4. And I can check and see if I got the right answer by substituting the value for y, which I said is negative 4, into my equation. 7 times negative 4. And I've got to substitute it twice here because I've got a variable on both sides. So 5 times negative 4 is negative 20 minus 8 equals 7 times 4, negative 4, sorry, is negative 28. So I've got a negative 20 plus a negative 8, which will give me a negative 28 equals negative 28. So my answer is correct. Okay, so now moving on. Now we're going to solve equations with variables and constants on both sides. So here we have a variable on each side of the equal sign. There's my equal sign. And we have a constant on each side. So now we have to decide. Okay, and before the decision wasn't really up to us because there was only a variable on one side, or there was only one constant on one side. But now we've got both on both sides. So now we really have to decide which side do I want to be my constant side, which side do I want to be my variable side. So I'm going to look at this, and I know that 7x is bigger than 6x, and so I'm going to subtract 6x to get rid of that, which means I'll be subtracting it from it on the left as well. So that's going to give me a positive x. So take a quick look at it and try to keep your variable positive. So that will help you determine which side you want it to be on. Normally, in most people feel more comfortable having the variable on the left-hand side anyway, so you end up with x equals or y equals. But take a look at what's going on here. So I'm going to make the left-hand side my variable side, the right-hand side my constant side. So I want to get rid of the variable that's on the constant side. So I'm just going to rewrite everything. I'm going to be subtracting 6x from both sides. 6x minus 6x plus 2. Okay, so now I've got 7x minus 6x, which will give me 1x, or just x, plus 5 equals, these x's are gone, and I'm just left with 2. So now I want to get rid of that 5, because it's on my variable side. I want my variable to be by itself. So x plus 5 minus 5 equals 2 minus 5. So now I'm left with x equals 2 minus 5 is negative 3. Okay, and I can check that. 7 times the value of x is negative 3 plus 5 equals 6 times the value of x, which is negative 3 plus 2. So 7 times negative 3 is negative 21 plus 5 equals 6 times negative 3 is negative 18 plus 2. Negative 21 plus 5 will give me negative 16 negative 18 plus 2 will give me negative 16. So negative 16 equals negative 16. Okay. Now, solve equations that need to be simplified. So sometimes before you can eliminate your variables or your constants, you need to really look and see if there's anything that can be simplified. So here we've got 3x minus 7 minus 2x minus 4 equals 1. So on my right-hand side, I only have a constant. That's it, nothing else. But look at the left-hand side. I've got two variables and I've got two constants. So the first thing I'm going to do is rearrange 3x minus 2x minus 7 minus 4 equals 1. So now I've got my like terms together, so I can simplify those. 3x minus 2x will leave me with x. Negative 7 minus 4 or plus negative 4 will leave me with negative 11 equals 1. Okay, so now I've got x minus 11 equals 1. Now I just need to get rid of that minus 11. So I'm left with my variable. So x minus 11 plus 11 equals 1 plus 11. So now I'm left with x, because that's cancelled out, equals 1 plus 11, which is 12. Okay, so make sure you simplify first. Look at everything that's there. So to solve an equation with variables and constants on both sides, first of all, choose one side to be the variable side, and then the other side will be the constant side. Next, collect the variable terms to the variable side. So that might mean that you eliminate from one side using the addition or subtraction property of equality. So add or subtract to remove variables or constants. Step 3, collect the constants to the other side. Same thing, using addition or subtraction property of equality. So add or subtract to get all the constants on one side. Next, make the coefficient of the variable 1, so the number that's in front of the variable, using the multiplication or division property of equality. So that basically means that you are left with the variables, because 1x is x. And then check the solution by substituting it into the original equation. It's a good idea to make the variable side the one in which the variable has the larger coefficient. This usually makes the arithmetic easier. So look at your variables. Whichever variable is bigger, then that's the side you want your variables to be on. Just like I did in the example here. I said 7x is bigger than 6x, so I want the side that the 7x is on to be my variable side. All right, so let's do a little bit of a practice here. So solve each equation. 4n minus 2n equals 4. So I've got two variables on this side. First thing I'm going to do is simplify. 4n, take away 2n will leave me with 2n equals 4. Okay, next step, get rid of that 2. So that's multiplication. I need to divide. 2n divided by 2 equals 4 divided by 2. 2 divided by 2 is 1. That leaves me with n, or 1n or n. 4 divided by 2 is 2. So n equals 2. Number 2, I've got negative 12 equals 2 plus 5v plus 2v. So now I've got constants on both sides. But the first thing I'm going to do is my like terms. Okay, I'm going to simplify first. So negative 12 equals 2 plus 5v plus 2v equals 7v. Okay, now I've only got a variable on the right hand side, so I want to get rid of that constant. So in order to get rid of that positive 2, I have to subtract 2, and I have to subtract 2 from both sides. So negative 12 plus negative 2 is negative 14 equals, this is gone, 7v. Now I need to get rid of that 7. So in order to do that, I'm going to divide both sides by 7. Negative 14 divided by 7 is negative 2 equals v. 7's are cancelled out, left with my v. Okay, let's move on to the next page. So here we've got some that are quite a bit longer and a little more complicated. So let's have a look at these. So let's go down to number 3. Negative 7x minus 3x plus 2 equals negative 8x plus 8. So we've got lots of variables here. We've got 2 on this side, 1 on that side. So first of all, I'm going to combine or simplify my variables on this side. So negative 7x plus negative 3x will give me negative 10x plus 2 equals negative 8x minus 8. Now I want to decide which side is going to be my variable side, which side is going to be my constant side. So negative 10, remember, is smaller than negative 8. So I want my variable side to be over here, my constant side to be on the left. So what I'm going to do is negative 10x plus 10x plus 2 equals negative 8x plus 10x minus 8. So now my variable's gone from that side. I'm left with 2 equals negative 8x plus 10x was 2x minus 8. Okay, now I want my constant gone on the right-hand side. So in order to get rid of a minus 8, I need to add 8 to both sides. So 2 plus 8 equals 2x minus 8 plus 8. 2 plus 8 is 10 equals 2x. This is gone. So now I need to get rid of that 2. So I need to divide both sides by 2. 10 divided by 2 is 5. 2 divided by 2 is 1, and it leaves me with x. So 5 equals x. Okay, so look and see if you can simplify first. If you can simplify first, do that first. Okay, and that's okay. Let's do number 5 in here. So I got to erase this in order to be able to get at number 5. Okay, so number 5, we've got negative 14 plus 6b plus 7 minus 2b equals 1 plus 5b. So first of all, I'm going to rewrite again so that I've got my like terms together. And then I'm going to simplify. So negative 14 plus 7 will give me negative 7. And then 6 minus 2 is 4b equals 1 plus 5b. Okay, so now I've got constants on both sides and variables on both sides. So 5b is bigger than 4b. So I'm going to have my constants again on the right, my variables on the left. Constants on the left, variables on the right. So I need to get rid of the 4b over here. So negative 7 plus 4b minus 4b equals 1 plus 5b minus 4b. So now over here I'm left with negative 7 because this is cancelled out equals 1. And then 5 take away 4 is 1b or just b. So now I've got negative 7 equals 1 plus b. Now I need to get rid of that 1. In order to do that, I'm going to subtract 1. So negative 7 plus negative 1 or minus 1 equals b. Negative 7 plus negative 1 is negative 8 equals b. So my answer is negative 8. Okay, so again, make sure, look at it, find your like terms, rewrite it so that your like terms are together, then simplify, and then start to eliminate. So do it one step at a time like I did here, writing everything down, because if you try to do more than one step in one line, then that's when you tend to make mistakes and you get mixed up. All right, so that's key question 20 in lesson 4. So take your time. There are 18 questions for you to do. Look and see if you can simplify before you actually start eliminating anything. Okay, so the next thing we're going to look at is the Cartesian plane. So that begins on page 13 in your lesson. So page 13, 14, 15, 16, 17, and 18 in your lesson. Make sure you do the support questions and check your answers at the end of the lesson. Okay, so coordinate plane or Cartesian plane, same thing. A coordinate plane is composed of two lines intersecting at a 90-degree angle. A lot of people say that's a graph. Okay, but you do make a graph with it, making them perpendicular lines at the point 0 and 0 known as the origin. So perpendicular lines are lines that cross at a point. The point where they cross we call the origin. The Cartesian plane extends infinitely or indefinitely in all directions. To show this, math textbooks usually put arrows at the ends of the x and y axes. So we have two number lines basically. One is a horizontal number line that extends in both directions. The other one is a vertical number line that extends up and down. That's the y-axis. So the intersection, the intersection of the x-axis and the y-axis, so the two lines crossing each other, results in the creation of 4 sections or divisions. So we call them quadrants. So the first quadrant is the upper right quadrant, second quadrant the upper left, third quadrant lower left, and fourth lower right. So if you're ever asked where is a point, which quadrant is a point in, this is the way they're labeled. Okay, remember the order: right, left, left, right. Okay, how to plot points on a graph. So if you're asked to plot the point 4 and 2, so these are our ordered pairs because one is a x and one is a y. So the first point is always the x point, the second point is always the y. So if you're asked to plot the point 4 and 2, whoops, let's hope this is going to work. There we go. You start at the origin. So you start at the place, the point where the two lines intersect. Then you plot your x point first. So your x point is 4. Whoops. So you have to go along the x line. 1, 2, 3, 4. The next point, the y, you have to go up or down because remember the y-axis goes up and down. So because it's a positive 2, I'm going to go up 2, and there is my point 4 and 2 on the graph. Okay, so let's practice. The next one, plot the points -5 and -4 and +5 and -3. So going to start at the origin again. There's my dot, and it's -5 this time. So again, remember, the first point is my x, the second is my y. So the x point, I have to go along the x line, left or right. Because it's negative, I have to go to the left, -5. And the y coordinate is -4. So for my y, I have to go up or down. Because it's -4, I have to go down 1, 2, 3, 4. So I go down as far as -4. And this is my point, -5 and -4. And that's in the third quadrant. And now my point 5, +5 and -3, I go back to the origin. So x is 5, y is -3. So 5 is along the x-axis, so I go along the x-axis to 5, and then y is -3, so I have to go down 1, 2, 3, and there is my, oops, +5 and -3. There's that point. Okay, plot the points 0 and 4 and -3 and 0. So start at the origin at 0, and now my x coordinate is 0, my y coordinate is 4. Because my x coordinate is 0, I do not go left or right. I stay right at 0. My y is +4, so I'm going up to 4, and my point 0, and 4 is right on the y-axis. Okay, the next one was negative 3 and 0, so I'm going to start at the origin. Negative 3 is my x point or coordinate, and 0 is my y coordinate. So x is negative 3, so I'm again left or right along the x. I have to go left because it's negative 3, and my y coordinate is 0, so I don't go up or down at all. I stay right there at 0, and this is where I would find negative 3 and 0. Okay. Okay, so now let's practice, do a bit more practice. So this one, locate each of the group of points below on the Cartesian plane, then connect the points to reveal the hidden shape. Okay, so our A points are all of these. So we're going to plot those and we're going to label them all A. So the first one is, starting at the origin, negative 9 and positive 3. So this is my x. Remember, the first one is x, so I have to go over negative to negative 9 along the x-axis, and it's positive 3, so I go up 1, 2, 3, and that's my first A. The next A is negative 6 and positive 6, so starting at the origin, negative 6 along the x-axis, and then positive 6, 1, 2, 3, 4, 5, 6. That's my second A. And the next one is negative 4 and positive 3. So starting at the origin again, going over negative 4, and then up to positive 3, and that's my third A. And then my next A, if you look, my last A is the exact same as my first A. So I don't need to plot it there because it's already plotted. So now I'm going to join my points, starting with the first one, up to the second one, down to the third one, and across. So I've made a triangle so far by plotting those points. Okay, so now my B points. I've got a first one is a negative 6 and a positive 6. So starting at the origin, back over negative 6. Whoa. Get back there, back where it was. Go over to negative 6 and positive 6. Okay, so it's right there, same spot that it was that I ended off with before. Get up there. That I didn't end off with, sorry, that I was at before. There we go. So that one's already plotted. So that one is also a B point as well. So my next one is positive 6 and positive 6. So go back to the origin. Go over to the right this time, 6, and up to 6. This is my B. My next B is positive 8 and positive 3. So go start at the origin, go over to positive 8, and then go up 3. So this is B. And then that was 8 and 3. Next one is negative 4 and 3. So over negative 4 and up 3, and that one's already there. That's where the A is. So now I join my points. So B to B to B and back to B. So now I have a parallelogram that I've joined to that. Okay, so now my next point, my C points, are negative 9 and 3, which is already here. That's my first A. Is negative 9 and 3, so I don't have to put a point there because it's already there. My next one is negative 9 and excuse me, negative 4, so I'm going down here, and that's a C. So this is a C. That's a C. The next one is negative 4 and negative 4. So start at my origin, go down to negative 4, go over negative 4. And then my last one is negative 4 and negative 3, which is already there. So negative 4 and negative 3. So this is C, and this one is also C. So now join my points. So C to C to C to C. And then my D's, first one is -4 and -4, which is, I go over, whoops, oops, get rid of that line. All right, so -4 and -4. So if I go over here, down -4, over -4, that's where C is. So this is also D, -4 and -4. And the next one is +8 and -4. So here, +8 and -4, which is right there. So that's D. And then last one is 8 and 3. So +8 and +3, which is also this point B up here. So now I'm just going to join my lines. So from D to D to D. So what I've drawn is a house, a very simple house, but I have drawn a house. Okay, so one of your questions, key questions, you will be asked to locate the points on the Cartesian plane and then join the points together to have it identify a shape. Make sure you do them in order. Don't look at them and just draw line to line to line wherever you feel like it. Do them the way I did in this example so that you get the correct shape. Okay, and then identify the points on a Cartesian plane. So if you know how to plot the points, you should be able to identify them as well. So here we're going to find point A, which is over here. So point A, to get to point A, I had to go all the way over here to -10. And then I went up to 2, so +2. So A is -10 and 2. Those are the coordinates of point A. So X first, Y second. So go along your X-axis first, Y-axis second. Okay, point B is way up here. So to get to point B, I start at the origin. I have to go along the X-axis to 6. So my X coordinate is 6. And then I go all the way up to get to B to 10. So 6 and 10 are the coordinates of, point B. Point C is over here. So starting at the origin, I go over to -8. And I go down 1, 2, 3, so -3. So the coordinates of C are -8, -3. D, down here, so same thing, start at the origin, go over as far as -8, and then I go down as far as -8. So my coordinates for D are -8 and -8. E is over here. So to get to E, I start at the origin. I go over 1. So that's far over as E is. And I go down 1, 2, 3, 4, 5. So -5. So if you're going down, it's negative. Or if you're going to the left. If you're going to the right or up, it's positive. F, right beside E. So I go over 2. And I go down -4. So F is 2 and -4. Okay, so that's how you name the points. Okay, so that brings us to key question 21. Name the point with the given coordinates on the following grid. So you have to look those up, find which one is which, write them in the chart below, the letters in the chart below. Number 2, write the coordinates of each point on the space provided, which is what I just did in that example. And then number 3 is locate each of the group of points below in the Cartesian plane, then join the points in each group to find the shape. And at the bottom, you're going to identify the figure, the shape that you created. All right, so that's it for our class today. When we meet again on Thursday, we'll continue on with Lesson 4, and we'll finish up Lesson 4 on Thursday, which will leave us with Lesson 5 to do next week. Okay, so try to get your key questions finished and submitted for marking. If you have any questions, please contact me. Other than that, enjoy the rest of your day.